Welcome to the deep dive. Today we're cracking open a really fundamental part of the Linux world, file permissions.
Yeah, super important stuff.
We've got a pretty cool set of resources to explore this with you.
Yeah.
There's this real-life situation like an organization fixing their permissions.
A practical example.
A big reference guide for Linux commands, and also a module that introduces the basics.
Right, and our mission really is to make these Linux file permissions totally clear for you.
Yeah.
We want you to get not just what they are, but why they're so critical for security.
Which is huge.
Exactly. And how you can actually manage them using the key commands. We're aiming for those aha moments, the light bulb moments, yeah. Where it clicks how the tech connects to like actual security practices.
Precisely.
Okay, let's dive right in then. So the absolute foundation is just understanding what these file permissions are in Linux.
Right.
Our project description source, it really hammers home how crucial managing them is for keeping a system secure. Absolutely. And the core of it, really, is this 10-character string you see when you list files.
Looks a bit cryptic at first glance.
It can, yeah. But as our sources lay out, describe the permissions string bit and the table in the module, this little string tells you a lot. The very first character, that just tells you what kind of thing you're looking at. Is it a directory, like a folder? That's a D.
Or just a regular file, like a text document.
Then it's a dash. Simple as that.
Okay. And then the other 9 characters.
Those fall into 3 distinct groups.
Yeah.
3 sets of 3.
Right.
And each set represents permissions. R for read, W for write, and X for execute.
And the order matters, doesn't it?
Totally. It's always the same sequence. First 3 are for the user, that's the file's owner.
Got it.
The middle 3 are for the group the file belongs to.
Okay.
And the last 3, that's for others, basically everyone else on this system.
User group, others, RWX. Okay.
Let's make it concrete. Think about that example file, project.txt. Its permissions were RWRWR. So that first dash means...
It's a file, not a directory.
Exactly. Then RW-nash for the user. What does that tell you?
The owner can read it and write to it, change it, but can't execute it, like run it as a program.
Perfect. And the next RVIS.
Same thing. Yeah. But for anyone in the files group, they can read and write too.
Right. And finally, R for others.
Just read only for everyone else. They can't change it, can't execute it. Makes sense.
See, not so cryptic once you break it down.
Okay, cool. So we can read the codes now, but how do we actually, see them on our system?
Ah, right. The essential command here is LLA.
LLA.
Yeah. Both the practical example and the reference guide point to this one. else is the list command, obviously.
Right.
The LL flag gives you the long format, the detailed view, which includes those permission strings, the owner, group, file size, all that good stuff.
And the A, what does that do?
The A is for all. It's super important because it shows you hidden files, too.
Ah, the one starting with a dot.
Exactly. Files like .basharg or configuration files, they're hidden by default to avoid clutter, but their permissions are often really critical for security. You wouldn't want just anyone messing with your shell configuration, right?
Definitely not. Okay, so ELASLA shows everything, long format, including hidden files and their permissions.
Precisely. And we have that image from the exemplar showing the output for the projects directory.
Yeah, I see it. You can clearly see the different entries. There's drafts, which starts with D.
So it's a directory.
Right.
Yeah.
And then .projecttx.txt.
Hidden file.
Starts with a dash. So it's a file, but it's hidden. And projecttx.txt, a regular file. And you see those different permission strings right at the start of each line.
Exactly. And seeing that projecttx.txt listed, thanks to the LSLAG, is key. Like we said, permissions on those hidden config files or maybe sensitive data files are just as vital, maybe even more so sometimes.
Yeah, you can imagine a hidden file with API keys or something.
Exactly. You don't want loose permissions on that.
Okay, makes total sense. So we can see them now. Let's get to the action part. How do we actually change these permissions if we need to?
All right. The command you need is chmod.
Chmod. Short for?
Change mode. Yeah. Both the reference guide and the intro module cover this one. It's your main tool for modifying file or directory permissions.
And I think the sources mention a couple of ways to use it. There's like a symbolic way.
Yeah, symbolic mode is probably the most intuitive way to start.
Okay.
It uses letters, U for user, G for group, O for others. You can also use A for all user group and others.
UGOA.
Got it. Then you use operators, A plus sign plus to add a permission.
Okay.
a minus sign to remove a permission,
Makes sense.
and an equal sign to set the permissions exactly to what you specify, overriding whatever was there before.
Add, remove, or set directly. Plus, minus, equals.
Right, and then you just use the permission letters.
Okay.
RWX.
Read, write, execute. Okay, so you combine those.
Exactly. The reference guide had that example. Chmod U plus RWX G plus RWXO plus RWX login sessions.txt.
Whoa, okay. Let's unpack that. U plus RWX dot adds, read, write, execute for the user.
Yep.
Comma dot G plus RWX dot adds, read, write, execute for the group. Comma dot O plus RWX dot adds, read, write, execute for others on that login sessions.txt file. So that basically gives everyone full permissions.
Precisely. Maybe not the most secure setting in many cases, but it shows how you combine them.
Right. But the real world example had more specific, targeted changes.
It did. That's where it gets practical.
Yeah.
So they realized maybe giving everyone a right access to project.t8.txt wasn't a good idea.
Yeah, probably not.
So they used chmod.o.8.txt.
Okay. O for others.
For remove.
WW for write. So take away write permission for others on that file.
Exactly. And the before and after images in the source clearly show that W disappearing from the last triplet of permissions.
Cool. Visual proof. And what about that hidden file, .projecttx.txt?
Right. That one was archived, so they wanted to prevent accidental changes. But they still needed the group to be able to read it.
Okay, so a few things needed changing there.
Yeah, so they combined changes using commas again. Chmod uwgw plus r dot projecttx.txt.
Let's see. UWW, remove write for user, .gw, remove write for group, .g plus r, add read for group, all on .projecttx.txt.
You got it. Protects it from modification, but allows the group to see the contents. Again, images show the permission string changing accordingly.
Oh.
It really drives home that hidden doesn't mean unprotected. You have to manage those permissions too.
Definitely. Okay, one more. The drafts directory.
Yes, the directory example. They wanted to restrict access, so only a specific user, researcher 2 could really use it.
And for directories, execute means something different, right?
Exactly. That's a key point. For a file, X means you can run it. For a directory, X means you can enter it, like CD into it, or access files within it.
Okay, so if you don't have execute on a directory.
You can't go inside, even if you have read permission on the directory itself, which would just let you list the names of the files inside. You need X to actually open the door.
Got it. So to stop the group from entering drafts,
they use trod gx drafts. Remove execute permission for the group on the drafts directory.
gx drafts. Makes sense. Stops them at the door.
Yep. The image shows that exitx vanishing from the group's permissions for the directory entry. It highlights that difference, file execute versus directory execute. Very important distinction.
This all feels very deliberate, like there's a guiding philosophy.
There absolutely is. It ties directly into something called the principle of least privilege.
Okay, I think our module mentioned that.
It did, yeah, under changing permissions. The core idea is simple but powerful. Only give users or processes the absolute minimum permissions they need to do their specific job or function, and nothing more.
So don't give everyone admin rights just in case they might need them someday.
Exactly. That's the opposite of least privilege. Restricting the draft's directory access mainly to researcher 2 by taking away group execute, GX. That's a perfect example of least privilege in action.
It prevents others who don't need access from accidentally or intentionally messing with those draft files.
Precisely. And think about the risks if you don't follow this. Our project description hinted at this initial problem. The permissions were too wide open.
Yeah, insecure.
Overly permissive settings are a huge security risk. It could mean unauthorized people reading sensitive data, modifying critical system files, or even executing malicious code. It's like leaving your front door wide open with a sign saying, help yourself.
Not ideal. Okay, so Chmod handles the read, write, execute permissions. What if the issue is who owns the file, or which group it belongs to?
Good question. Linux has other tools for that. Our reference guide mentions several under Manage Users and Their Permissions.
Like what?
Well, there's Chown.
Chown.
Yeah, change owner. It lets you change both the user owner and the group owner of a file or directory. Super useful if someone leaves the team or you need to transfer responsibility for some project files.
Okay. That seems pretty essential in a team environment.
Definitely. And then you have commands like user add and user del for creating and removing user accounts entirely. In user mod, for modifying existing accounts, maybe adding a user to a new group or changing their home directory. These manage the identities that the permissions apply to.
So Shroud manages what they can do, and things like Chown and user add manage who they are.
That's a great way to put it. It's all part of the bigger picture of access control. We won't dive deep into those today, but it's good to know they exist for more advanced user management.
Absolutely. And, Linux can feel vast. If you get stuck or just want to learn more about a command like shroud or nels, what are the go-to resources?
Well, the online community is amazing, huge amounts of forums and tutorials, but don't forget the help built right into Linux itself.
Oh, yeah.
Our module mentions this under Linux resources. The man command is your friend.
A man, like manual.
Exactly. Just type man followed by the command name, like mantrod or mandels. It gives you the official manual page, usually with tons of detail and options.
Okay, that's handy.
There's also apropos, which helps you find commands related to a keyword, and Watis, which gives a very brief description. They're incredibly useful tools for learning right there on the command line.
Man, apropos, what is? Good to remember.
Definitely worth exploring.
Fantastic. Okay, so let's wrap this up. For you, the learner, the key takeaways are: you've now got a solid handle on what those Linux file permission strings mean.
That 10-character code.
Right. You know how to use lslay to see them in detail, including for those sneaky hidden files.
Sure.
And you know how to use CRUD, especially with symbolic mode, to actually change those permissions, adding, removing, setting reads, write, execute for user, group, and others.
And why you'd want to do that, adhering to that principle of least privilege to keep things secure.
Exactly. Only give the access that's truly needed.
Mm-hmm. And maybe one last thing to chew on.
Go for it.
Think about the ripple effects of getting permissions wrong. Consider different places, your own laptop, maybe a small company's web server, or even like a huge hospital's patient record system.
Ooh!
What kinds of vulnerabilities could pop up just from permissions being too loose? What could actually happen? It really underscores why understanding this stuff isn't just technical detail. It's fundamental to security in almost any system.
That's a great point. Food for thought indeed. Thanks for breaking all that down.
My pleasure. It's important stuff.